Oi, what's crack-a-lackin'? Welcome back to Fantastic Chemistry Podcast. My name is Pete. I'm your host. Tuski is right here. He showed up today. Hey, he's my co-host. All right. We're proud to present chapter 11. We've been a long way. Woohoo! So we got chapter 11, 12, 13, 14, and 16. So 5 more chapters, including this one. Okay. So hang in there then. All right. So this chapter we will talk about the chemistry in solution. All right. Before to get to that point, so let's talk about how do we make solution. Here we go. We use water. All right. Let's talk a little bit about water. So water, I'm sure you guys know water is really important, right? So we use water for drinking, for cleaning, for in the automobile, making electricity. 3/4 of Earth filled by water, right? Plants use water in photosynthesis. We use water. Well, there's was it 75% of our body is water, I think, something like that, right? So there's a lot of our water in our body. So our cells, enzyme, DNA can function well in water. We use water for leisure and for habitat for like others living things, right? So water is really important, and only water can do this because water have appropriate property for all these uses, all this application. Okay, let's talk about the structure and property of water real quick. All right, so water bent. There's a shape. The angle right here is about 105 degrees. Covalent bond can form hydrogen bond. All right, the unique properties of water. I think we mentioned this like last chapter, I think. So strong adhesive forces, high cohesive forces, and high surface tension. So a little thing can float around like on it. And we spent quite some time talk about the high specific heat capacity of water. So heat in a hot day, so water just warm, but not as hot as some other objects. Okay, and that keep everyone's alive, basically. All right. So and water, one of the many great property of water is a common solvent. All right. So since water is highly polar, so it can dissolve quite a lot of ionic compound, dump sodium chloride in water. So what happened to it? Let's take a look at the molecular level. So we have sodium ion, chloride ion, and these are water molecules. Each water molecule will go surround the ions and pull them apart. Look like this. Oh, when it surrounds, so the chloride is negative, right? It has is negatively charged. The water will use hydrogen, which is partial positive, stabilize it. And sodium cation, which is positively charged. Water will use oxygen, which is partial negative, so gonna be opposite charge and surround it. All right, and we call ion dipole interaction, which is pretty strong, right? Chloride and sodium are pretty happy, pretty stable, and then pull this apart, right? And the solvation start from the surface and eventually the whole thing look like that. All right. So water is a common solvent, can dissolve a lot of compounds. Okay. So all right, write the hydration equation. So hydrate mean water. So add water into it. So sodium chloride dissolve. You get sodium ion and chloride ion. And from solid go to aqueous. Sodium nitrate also soluble, if you remember. So group 1 and the nitrate also soluble. So you get sodium ion and nitrate ion. This is in aqueous, so they are soluble. Ammonium. So you see ammonium. You should remember the solubility rule. Group 1 ammonium are soluble, right? The -1 anion like nitrate, chlorate, perchlorate, acetate, these guys are soluble. So ammonium sulfate, so totally soluble here. Okay. Silver chloride. What happened? What's the hydration equation of silver chloride? Does it look like that? No, silver chloride precipitated in water, so water cannot dissolve silver chloride. It stays as a solid. All right, so look back into the solubility rule. So make sure you have that in hand. Okay. All right. Water can dissolve non-ionic compound as well, not just the ionic compounds we saw like sodium chloride earlier. Right. So for example, you drink beer. The main component of beer is besides water, of course, is ethanol. right? So ethanol is polar, so partial negative on oxygen, partial positive on hydrogen. Water can surround it, same thing, use the opposite charge and stabilize or solvate or dissolve. You can use any word there, the ethanol, okay? So polar compound tend to soluble in water, all right? So look like, and for non-polar compounds, so look like oil. You probably know that oil is immixable with water, right? The polar group is right here, but the rest are non-polar. There are too many non-polar groups, so water cannot dissolve these guys. Okay, so water can dissolve a lot of compound. Now we have a solution, right? So we have a solution of ethanol. Okay, let's talk about the solution right on the next video.